Hello students. So in this video we'll discuss about predictive parsers, especially the LL1 parsing technique. And the first technique to construct the predictive parsers, we need first and follow. So in this video we'll discuss first only. So the next video we'll discuss follow. So first of all, predictive parser. In the last video we have discussed about backtracking and also recursive descent parser. So top-down parser is mainly divided into three. So this LL1 is the third parser, where L is nothing but scanning the input from left. And the second L is nothing but using the leftmost derivation. And one is nothing but the look ahead symbol. Look ahead symbol means while you are reading the input buffer, how many symbols we can read at a time. So one means you have to read only one symbol. Two means you can read two symbols at a time. Three means you can read like that. So 0 means without worrying about the locate symbol, we are just substituting the production. That's the meaning of it. So the intention of every parser is to check whether a statement is syntactically correct or not. So from the predefined grammar. So once you got the tokens from the lexical analysis, now I just want to check whether this A plus B is the input. So where the dollar is denoting the end of the string. It denotes end of the string or starting of the string. Sometimes if you keep here, then how can you generate this input is syntactically correct or not means. So A plus B could able to generate the parse tree for this A plus B from the table where our context free grammar is represented as a table. So you can see this. So our grammar, like expression grammar, is represented as a table. So once the table is constructed, how we have to construct the table, that we'll discuss in the next slide, next video. So then if the grammar is represented as a table and you are given this input string, so if you could able to parse this input string from the grammar, then we can say that the statement is syntactically correct. So to check whether the statement is syntactically correct or not from the given grammar where it is represented as table, with the help of stack, we use a predictive parsing program or algorithm, right? So I'm assuming that the grammar is already represented as table. So how we have constructed it, that we'll discuss in the next video for a grammar. But assume that for a grammar is represented as LL1 parsing table, right? It is already represented. Then the X is top of the stack. Here you can say that this X, whatever it is, that is denoting with the X, top of the stack. And the A is the locate symbol here. So whatever the symbol we are taking, this is A locate symbol. And this is M of X comma A, where X is denoting the row and A is denoting the column here. So this is nothing but X and A, right? So what is the first step? If X equivalent to A equivalent dollar, successful completion. If X equivalent to A but not equivalent dollar, pop off the stack and increment the output. So if it is not 1 and 2, in the third step, if X and A, for example, E and ID, so X and A equivalent to A and ID, then we have to replace this X in the stack with UVW such that U is occurred as the top of the stack. Means what? Assume a situation like this. So dollar $X and the input symbol is A. So in this case, if X, M of X comma A is some production like X tends to UVW, then pop X and push UVW such that U should be occurred as top of the stack. Means we have to push reverse, push W, push V, push U, then continue the process, right? So let me just go with the string here. See, our input string is ID plus ID star ID dollar, and I'm going to take it from this table. Okay, so then first the stack initially contains dollar and top of this starting symbol, as I mentioned, right, initially. So now X is E ID, then we have to take the production from M of X comma ID, means what? M of E comma ID. E comma id. What is the production in E comma id? E tends to te dash. So if it is E tends to te dash, right, te dash, so we have to replace E with the te dash. Then you got like this, te dash dollar. Now what is x again? T. What is a? Id only, we have not changed it. Then tid, what is the production? So tid, again t tends to ft dash. Here see, t tends to ft dash. Then what you have to do, replace the t with ft dash such that f should be occurred as top of the stack. Now x is f, a is id, what is the production? F tends to id, again f tends to id. So then you can write f, replace f with the id. Now see, x is id, a is id. If both are same, what we have discussed, if both are same, x equivalent a and dollar not equivalent dollar, pop up the stack and increment the input symbol. Means we have to pop up this id and we have to increment the a to plus. So now what will happen? X is t dash and a is plus. T dash a, what we got? So t dash a, right? A means what it is, plus, sorry, a means plus. T dash plus, what it is? Epsilon. So you have to replace the t dash with the epsilon. Then I got e dash comma dollar. Okay. So then again x is e dash and locate symbol is plus. Then what is the production we are going to have here? See, right? E dash tends to plus t dash. Then what will be happened here? So we have to replace the e dash with the plus t dash. Then both are same. Then pop up plus and increment the a. So like that. Then t id. So you have to take the production ft dash. Then f tends to id. Like just repeat the process whatever we have done. Right. So simply, if both are same, then you have to pop out. If not same, then take the production and substitute. So if you do like that, then finally you are going to get dollar and dollar. So if x equivalent a equivalent dollar, we can say that successful completion. Just iterate the process what we have done, then definitely you'll get the successful completion. So instead of explaining all the stack symbols. So but in textbook we have another method that we'll discuss again, because we have to repeat this step once we are done with the construction. So then we get a doubt like, see how we got this table for the grammar, right? So that we have to do. So to construct this table for the grammar, we have to follow this algorithm. For each production a tends to a, find first of alpha, and for each terminal in first of alpha make entry a tends to. Of course you are not getting it. Just let me tell you that to construct this table, okay, we need two techniques. One is first of alpha and another one is follow of a, right? So if I repeat these steps again also you won't understand now, but guys, once we are done with the first and follow, so again I'll come back to this construction of the table. At the time I'll again explain this algorithm, right? So I just wanted to mention you that to construct the table we need to follow this algorithm, but to execute this algorithm we need to know how to find the first and how to find the follow. So in this video, first we'll discuss about the first, then next video follow, and after that we'll discuss the construction of table. So at the time I'll give the same algorithm once again, right? Let me go with this. First of alpha. So first of alpha will give you the set of terminals, guys. The first set never ever contains the non-terminals. It should have either terminals or epsilon, but it never contains epsilon, right? Then the algorithm of first is, if x is a terminal, means what? First of x. If x is a terminal, then first of terminal is terminal only. If x is a non-terminal and x is deriving epsilon, then first of x equivalent to epsilon, you can take it, right? So let me just write down examples. For example, first of a is a only because a is a terminal. For example, t tends to epsilon, then you write first of t. As t is a non-terminal and having epsilon, you can take it. Then go for the third one. This is important. If x is not a non-terminal and if x is not a terminal and x is a non-terminal but not epsilon, means if x is deriving some productions like y1, y2, y3, then you can write first of x equivalent to first of y1. You have to consider only y1 if y1 does not derive the epsilon. Right? What if y1 derives the epsilon? Then first take the first of y1, then remove the epsilon and find out the first of y2 and y3. Same. First of y2, y3 means first of y2 only. When if it does not derive the epsilon. If it derives the epsilon, what we have to do again? We have to take the y3. Let me explain with a simple example, guys. See here. So first of E, nothing but first of T. So first you have to go for the first of T. First of T is nothing but first of F. So then what you are supposed to do? First you have to find first of F. First of F, guys, listen here, we are having two productions. What is the first symbol? Terminal, take it. What is the first symbol? Terminal, take it. That's it. And first of T dash, you go in a bottom up approach, better. First of T dash, what is the first symbol? Terminal. What is the first symbol? Epsilon. If it is terminal, take it. Epsilon, take it. Well and good, right? Then go for T. First of T is what? First of F. We have already found the first of F, right? What is it? Open brush and ID. That's it. First of E dash, plus and epsilon. First of E, it's nothing but first of T. What is first of T? We already found. Open brace ID, like that. Same way you can go for it. So you can go for first of bottom up approach, right? First of C, terminal, take it. Epsilon, take it. And same way, first of B, if first symbol is terminal, take it. Epsilon, take it. Now you'll get the difference here, guys. Listen. So first of A means first of D. Terminal, you take it. First of B, we already find what it is. G. And if it is epsilon, then you have to go to the next symbol. Don't take epsilon directly. If there is a symbol after that, go to that. So what is the first of C? H comma epsilon. Epsilon means again you have to go to the next symbol. As we don't have any symbol, then you have to take it. Guys, epsilon is a key to go to next symbol. So whenever you get epsilon, go to next symbol. If there is no, then you take it. If you didn't understand, just go for the next one. See, first of B, we have to take each and every first symbol here. So first of B, what is first of B? G comma epsilon. Take G and epsilon means go to next symbol A. Now you didn't get the A epsilon here now. See, because epsilon we got for B, that's why I've gone to A only. Epsilon is a key to go to next symbol. Same way, first of C, H comma epsilon. Take H. Epsilon means go to the next symbol. B, take B. As B is not deriving the epsilon, don't go to the next one. Same next A. First of A, D, G, H epsilon. Take D. Already G is there, H is there. Epsilon is there, then go to the next symbol. C. First of C, H comma epsilon. Take H. Epsilon means go to the next symbol. First of B, G comma epsilon. So already H is also there, don't need to take again. G is also there, no need to take. And epsilon, go to the next symbol here again. See, as there is no symbol here, then I am taking the epsilon. I didn't take for this, take for this because B are not deriving. But here all are non-terminals and all are deriving epsilon. That's why I have taken this. So here epsilon is the key to go to the next symbol. Remember that. So whenever you get epsilon, don't take it directly. So the intention of epsilon is go to next symbol. Right. So here A is you have to take. Right. Then epsilon, go to C, otherwise don't go. If it is epsilon, don't go to B, otherwise don't go. If it is epsilon, then you take it, otherwise you are not supposed. So in the next we'll discuss about follow.